So the whole chapter that we're going to do next is on what we call trig identities, right? And trig identities are basically equations that involve trig functions, right? Such that the right side equals the left side. So it's like relationships more than anything else. So for example, look, the first set of identities are these reciprocal identities, which you guys already know these, right? You know that sine is 1 over cosecant, cosecant is 1 over sine. You know them. You didn't know that these are identities, okay? They're basically relationships between the cosecant and the sine, the cotangent and the tangent. So, you know, these are the reciprocal identities. And then we also have two quotient identities. Tangent is sine over cosine. Cotangent is cosine over sine. Anything new here? No, right? We know this already. Okay, we know all this already. So here, if cosine is 3 over 4, right? Find secant of theta. Well, okay, we know that secant of theta is 1 over cosine of theta. So that's just the reciprocal 4/3. That's it, right? We just used an identity. And we were doing this all along. You just didn't know that it was called an identity. But they do get a little bit more involved, so you might have a few more steps. So for example, for this first one, if secant of x is 5 over 4 and tangent is 3 over 4, what's sine? Well, a good strategy is to write all of these in terms of sine and cosine, right? So secant of x is 5 over 4 means cosine of x is equal to what? 4 over 5. Now, tangent of x, what is tangent of x? It's sine x over cosine x, right? That's equal to 3 over 4. And so there are lots of ways to do this, but one way is just focus on this. We need to find sine of x. Is there any way to solve that for sine of x? Can I multiply both sides by cosine of x? Yeah? So can I write sine of x is equal to 3 over 4 times cosine of x? And now that's 3 over 4. What's cosine? 4 over 5. So that is 3 over 5. Okay? All right. So you basically have to like massage the identities to fit into each other. Okay, just like restructure them. Okay, now let's talk about the Pythagorean theorem. Take a look here for a minute. You've got, you know, an angle here, and we've been saying how this horizontal side is cosine and the vertical side is sine, right? Now, if I were to call this A and this B, right? That's a right triangle, isn't it? So can I say that A squared plus B squared is equal to 1 squared? Yes, right? Right? But now, what do I also know? That when this is an angle on the unit circle, that side, vertical side of the triangle is sine of theta, right? So for A, I can substitute sine of theta squared. For B, I can substitute cosine of theta squared equal to 1. Okay? Now, another way to write that so it's simpler, instead of sine of theta parentheses squared, is sine squared theta plus cosine squared theta is equal to 1. Okay, where did that come from? From the Pythagorean theorem, yes? And this is a trig identity because you have one side of the equation equal the other one. So we call this the Pythagorean identity. Okay? And guess what? You have to memorize this. Okay? So even like next year, even 2 years from now, when you least expect it, this will pop up. Sine squared theta plus cosine squared theta is equal to 1. All right? Now, this sine squared theta plus cosine squared theta, it's got buddies. Okay? Because look, let's take sine squared theta plus cosine squared theta equals 1. And just for fun, let's divide all of these by cosine squared theta. Why? Just for fun, just because we can. So I'm going to divide this by cosine squared theta, cosine squared theta, cosine squared theta. Okay, what's sine over cosine? Tangent. Okay, now, sine squared over cosine squared is tangent squared. Sine cubed over cosine cubed is tangent cubed. Okay, so this will become tangent squared theta plus, what's cosine squared over cosine squared? 1 equal to 1 over cosine is secant. 1 over cosine squared is secant squared theta. And look, that's the next identity. You see that? You see where it came from? Okay, so now look at what we're going to do. We're going to take sine squared theta plus cosine squared theta, and this time divide equal to 1. This time divided by sine squared theta. Now what do we get? Sine squared over sine squared is 1. Cosine over sine is cotangent. When you square both of them, is cotangent squared. Equal to 1 over sine is cosecant, cosecant squared theta. And look, this one is the other Pythagorean identity. Okay? So there are 3 Pythagorean identities. That's the basic one, and then you've got those 2. So now, do you memorize all of them? Well, first, memorize that first one. And then, as long as you know how to derive the other 2, if you need to, you can always come up with them, right? So even if you forget, eventually you'll use them enough that you'll commit them to memory. Okay, so let's take a look at this one now. Cotangent is equal to 2, okay? So cotangent is 2 over 1, or just 2. Cosine is less than theta. Find sine and cosine. Okay, so first, cotangent is positive 2, means you want the quadrants where cotangent is positive, so that's here and here. Cosine is less than 0, cosine is negative here and here. So our angle is going to be in quadrant 3. Okay? Now, I know you can solve this using a triangle, but for this chapter, we're going to solve them only using the identities. All right? So, what you have, or what you're given, is a cotangent. What you need is a sine and cosine. Now, you want to look through your identities and you want to see if there is any identity which relates cotangent to one of the ones you need. Okay? So, is there an identity that relates cotangent to something else? Well, the only one where cotangent shows up is this one. Oh, shoot, but that goes to cosecant. Oh, but cosecant is just 1 over sine, right? So I can totally use that one. So that's the one I'm going to use. So let's go ahead and write that. So cotangent squared theta plus 1 is equal to cosecant squared theta. Okay, what's cotangent? 2 squared plus 1 is equal to cosecant squared theta. So here, 5 is cosecant squared theta. So go ahead and find cosecant of theta. Take a square root, take a square root. So cosecant of theta is plus or minus root 5. So what's sine of theta? Plus or minus 1 over root 5. But now, what quadrant are we in? Third quadrant here. In that quadrant, is sine positive or negative?
Negative.
Negative. So I got to take this one. Okay? In quadrant 3, sine is negative. So sine of theta is negative 1 over root 5. Okay. But now I also need cosine. Is there any way to find cosine? What do I have now? Cotangent and sine. Anywhere I can find cosine? I can definitely use that one. Sine squared plus cosine squared equals 1. What's another one I can use? I can also use cotangent of theta is cosine over sine. Right? Huh? Yeah. So always go for the easier one. Right? Because we don't want to be like masochistic, right? You guys know what that means?
No.
So cosine of theta is sine of theta times cotangent of theta, so negative 2 over root 5. And the thing is, usually if you don't use another Pythagorean identity the second time, when you fix it for one quadrant, it'll just carry over for the other one. Okay? All right, so lots of times when we start doing trig, students are sort of like frustrated, and they express their frustration to me, and they're like, Miss Malikan, this is so, why is like sine, paired with cosecant, and like secant with cosine, like the words don't go with each other, but then, there's like other relationships, like why is it sine and cosine, but they don't seem to be paired with each other, right? Well, here is why. Okay. Next, what we're going to talk about are called cofunctions. Okay? So take a look at this for a minute. Suppose you have a triangle like this, okay? And suppose this is alpha here. Suppose that's 30 degrees. How do you know what beta is? I mean, we know it's going to be 60, but what would you do to find it? Is that 90 minus this angle, right? So that's 60, right? So suppose you do have a 30, 60, 90 triangle. Do you remember how, like in the unscaled one, it was 1, root 3, and 2? You remember that? Okay. So what's sine of 30 in here? 1/2, opposite over hypotenuse. Okay, what's 90 minus 30? 60. So what's cosine of 60? 1/2. Do you see what happened there? These two angles together add up to 90 degrees. They're complementary. And when you have two angles that add up to 90 degrees, sine of one equals the cosine of the other. They're called cofunction identities. Okay? So suppose you have an angle like this. So suppose you have an angle of you have an angle of 40. Sine of 40 is the same as cosine of what angle do you think? 50, 90 minus. Okay? You see what I mean? So tangent of, 37 is equal to cotangent of what angle? I'll give you a tough one now. 53. Okay? So secant of 20 is what of 70? Secant, cosecant. Okay, so you see where the relationship lies? It's the cos, sine, cosine, secant, cosecant, tangent, cotangent. That's why they have the same name. Right?
Is that really why they have the same name?
Yeah. They're co-functions because cosine, cotangent, cosecant. They're buddies. They're like co-buddies. Right? Yes. They're like little partners. They're little partners in crime. It's like dynamic duo.
Yeah.
It's like, like the Robin to the Batman. You know what I mean? Like, right? Yeah.
It's tough to be the Robin,
right? Yeah, but they're like equal. Okay. It's like Ben and Jerry.
Oh.
Yeah. It's an equal relationship. I don't know. Yeah, I know. How equal are they?
Ben and Jerry like the interview?
Oh, I know. There was a. The way the cofunction identities are usually written is sine is the same as cosine of, instead of 90 minus theta, it's pi over 2 minus theta, right? But remember, it's in that order, 90 minus, pi over 2 minus, not theta minus, okay? Now, the next thing we're going to talk about are the odd and even identities. We've kind of been talking about it before. Do you remember how I kept asking you guys about, you have an angle theta and you have an angle negative theta, okay? This is the sine of theta. This is the sine of negative theta. What happens when we switch between an angle and its opposite angle? The sine of that angle also goes from positive to negative and vice versa, right? Well, that's actually an identity, okay? Sine of negative theta is the same as negative sine theta. The way I want you to think of it as if there is a negative inside here, the sine kicks it out to the front, okay? And same with the cosecant. The cosine, remember, this is the cosine of theta. It's also the same as the cosine of negative theta. So if you remember that, good, perfect. But also remember that if you have a negative inside the cosine engulfs that negative so it goes away. Same with the secant. Tangent also kicks out the negative so it comes to the front. Why? Because tangent is sine over cosine. So it'll be like negative over positive, negative always. So I like to say that for the people who like to have the background information. For all practicality, however, if it's sine of negative angle, just take it outside. Cosine engulfs and it goes away. Okay, so take a look at what we have here. Cosine of x is negative 0.75. What's sine of pi over 2 minus x? Well, sine of pi over 2 minus x is the same as cosine of x, right? Remember from this identity, look here. Sine of 90 minus an angle is the same as cosine of the angle, right? And what's cosine of x? In the problem, what's it given to us as? Negative 0.75. So it's negative 0.75. Now, so this is sine of pi over 2 minus x. This is sine of x minus pi over 2. What's the difference between the two of them?
It's like negative.
One is the negative of the other, right? So compare this. One is pi over 2 minus x, one is x minus pi over 2. So let me ask you this. Suppose you have 5 minus 2 and 2 minus 5, just like we have here. one minus the other, or the other minus the other, right? What's the difference between them? One's negative, one's positive. So the difference between these two is it's the same, but this is the negative. So this is sine of a negative angle. What happens when you have sine of a negative angle? The negative comes out. So this is like sine of negative pi over 2 minus x. And that negative comes out. So this will be negative 0.75. That's positive 0.75. Okay? All right. Now, most of the time, okay, what you're going to be using these identities for is to simplify trigonometric expressions. So when you have something, you're going to have something like this, and you just have to simplify it. Okay? All right. And, okay, and there's always this question about how simple is simplified, right? Well, first, to simplify, okay, right, or you should end up with sine x or cosine x or some combination. And then there should be no more like simplification that can be done, okay? No more simplification can be done. Okay. Yeah.
When you say you only want sine of x or cosine of x, it would be like if we had tangent, we would just make it sine of x over cosine of x?
Yeah, so if you end up with sine over cosine, you can leave it that way, or you can write it as tangent. Okay. You'll see. Yeah. Okay? Yeah. Okay. So let's simplify this one. So look, here I have 1 over cosine. I can't do much with that. But look at this other term. I have a 1 and plus or minus a trig function squared. So when you have a 1 in conjunction with a trig function squared, you have to think of the Pythagorean identities. Which Pythagorean identity has a sine squared? That first one, okay? So why don't we write that down? Sine squared theta plus cosine squared theta equals 1. What you want to do now is make this look like that term that you have, 1 minus sine squared x. Okay? How can you do that? How about if we subtract sine squared x from, you know what, let me change these to x's because the problem is in x's. How about if we subtract sine squared x from both sides? What do we have now? Cosine squared x equals 1 minus sine squared x. Is everybody okay with how I did that? Yeah? Now look. Here I have 1 over cosine x. And what did I just say 1 minus sine squared x equals to? Cosine squared x. So if 1 minus sine squared x is the same as cosine, can I take out the 1 minus sine squared and replace it with cosine squared x? Yeah. Yep, I can. And now I have 2 cosines in the numerator, 1 in the denominator. It's like having x squared over x. You can cancel 1 from the top and 1 from the bottom. So you just end with cosine x. Isn't that lovely? right? Okay. So in here I have like one example of each type that you'll run into. So this is one where you had to sort of substitute with a trig identity, with the Pythagorean identity. Here is one where you have to factor. Okay? Look at what we have here. Cosine, tangent, minus sine cosine squared. So you know what? Before I do anything, why don't I rewrite the tangent as sine over cosine? Okay? Minus sine x cosine squared x. Oh my God, what happens now? What does happen now?
You can cancel the cosines.
You can cancel out these cosines. So I have sine x minus sine x cosine squared x. Okay? Now I can factor out a sine x. Okay? Okay, so when I factor out a sine x from that first term, what do I have left? 1 minus, if I factor out a sine x from the second term, I have cosine squared x left. Okay. Now I run into the same situation. Sine x, I can't do anything about. But look at what I have here. A 1 plus or minus something squared, a function squared. What should those remind me of? The Pythagorean identity. So grab the one that has a cosine squared. That's this one. Okay? What should I do to make it look like 1 minus cosine squared x? Subtract cosine squared x. So sine squared x is 1 minus cosine squared x. So if I go back here, I have sine of x. And look, that whole term, right? Look, match it with this 1 minus cosine squared x. That equals sine squared x. So I can take that out, replace it with sine squared x. And now I have 1 sine times 2 more sines. How many sines total? 3. So that's sine cubed x. Okay, yes. When you have two fractions like this, you have to do a common denominator. All right? Add using LCD. So here, what's going to be the common denominator? Exactly. The common denominator is going to be 1 minus secant x, 1 plus secant x. So the way to add these is you multiply each term by the whole LCD. So 1 minus secant x, 1 plus secant x. In the first term, 1 minus secant x cancels. So I have secant x, 1 plus secant x, minus. This cancels. Oops, that doesn't cancel. This cancels. So I have secant x, 1 minus secant x. Okay. Now, let's distribute here. secant x times secant squared x. I'm sorry, plus, not times. Okay? Minus secant x plus secant squared x over. Okay, what do we got there? So if you have 1 minus x, 1 plus x, right? A minus b, a plus b, huh? It's difference of two squares. So you square the first one, you get 1, minus, you square the second one, secant squared x. And then it kind of looks like it's getting way too complicated and all hope is lost. But you have to divide and conquer. See what you can do from the numerator. Do you see how you can cancel out, like secant minus secant goes away? And then what do you have left? 1 secant squared plus another secant squared, 2 secant squared. Okay? Over 1 minus secant squared. Okay. What do you think we can do about that denominator? What does that remind us of? The Pythagorean identities. Look, because you have a 1 minus something squared. So let's go see. Which one has a secant squared? Oh, look, it's this one. Okay? So let's see. Tangent squared x plus 1 is equal to secant squared x. Can we change that to 1 minus secant squared x? What happens if I subtract secant squared x? I have 1 minus secant squared x. But what am I going to do with the tangent squared to move it to the other side? Subtract, and it becomes negative. Okay? So let's see what we have now. 2 secant squared x over negative tangent squared x. Okay? Now, can I simplify that further? Yeah, right? Because what's secant? 2 over, okay, so secant is, so this is 2 times 1 over cosine squared x. And what's tangent? Negative sine squared x over cosine squared x. What happens now?
Oh, because, yeah.
Remember, same denominator, top and bottom, they cancel. So let's see what we have left. I have 2 on top, negative sine squared x on the bottom. And then we're done. Yeah.
You just put the negative like on the side of the...
Right. You can also write it like this.
Oh, and then because the negative tangent squared x was in there, and we know that it's not sine x or cosine x. That's how we simplify more. Okay.
Okay. So next one. Look at what you have. 1 plus tangent squared. Again, you have a 1 plus something squared. Is that an identity? That is so an identity. Look, 1 plus tangent squared. We don't have to do that one, and we don't have to do anything to that one. It's just secant squared x over cosecant squared x. But look, secant is 1 over cosine. Cosecant is 1 over sine. Okay, sadly, nothing cancels there. But I can say that's the first fraction times the reciprocal of the second fraction. And what's sine squared over cosine squared? Tangent squared. So that one, you can leave it as sine squared x over cosine squared x, or you can write tangent squared, and I'm fine with both. Okay, last but not least, do you guys remember ln's? A little? Do you remember logarithms? A little? Just a little?
Yeah, I remember the name.
Yeah. Okay. So here's what you learned back in Algebra 2. ln of A plus ln of B is ln of A times B. And you also learned ln of A minus ln of B is ln of A over B. Is this ringing any bells? Ring a bell?
Maybe like a bell really far back.
A far, far away in a faraway land. Yes.
When would we learn? Like what?
Chapter 8
Is that like one of the?
and Algebra 2. One of the last chapters. But this is all you need to know for now. Okay. We're gonna do logarithms like legit for real, like later on in chapter 3. Okay. So ln of something minus ln of something is ln of one over the other. So here I have ln of sine x minus ln of cosine x. Well, because, sorry, dry throat. Because there is a minus in front of the ln's, we subtract the stuff inside the, we divide the stuff inside the ln's. So I get sine x over cosine x. Okay? Now, what's up with these absolute values? You know why? Because inside, so if you have ln of x, that number inside the ln should be greater than 0, always positive. So if there is a chance that it might turn out to be negative, you have to put absolute values around it. So now, what do we have here? This is ln of, what's sine over cosine? Tangent x. Now, here's the question. Is there ever a possibility for a tangent to be negative? Yeah, right? It's negative half the time. If there is, then you must put absolute values around it to ensure tangent x will be positive. Okay? All right.